Hello everyone, my name is Saili Kadam. In our last video, we discussed different types of machine learning like supervised, unsupervised, semi-supervised. In this video, we will be talking about supervised learning and understand what is KNN algorithm. So let us get started. So before starting KNN algorithm, we should first understand what is classification and what is regression. So basically, what is classification is nothing but we are trying to classify a new data point into a category. In our previous video, we discussed an example that we are trying to predict whether the new mail is spam or not spam. So what exactly we did? We gave 1000 mail that were spam, 1000 that were not spam. So the model tries to find out the patterns, formats in that mail and try to predict what will be the new mail. So what is this? Like spam, not spam, or pass or fail. These are the categories to which a new data point can belong to. So when we are trying to find out to which category a new data point will belong to, that is classification. In classification, we don't have an exact number or exact value as the answer. We simply have different categories and we are simply trying to find out to which category a new data point will belong to. Whereas in regression, we try to find out, or the output of regression is a value. A number is always the output of regression. So when we are trying to find out or we are trying to predict what will be today's temperature or what will be the price of the house or what will be my salary after 10 years. So all this, they will have an exact answer or they will have a number as an answer. So the basic difference or the most important difference in between classification and regression is classification will predict a category or it will predict a class, whereas a regression will predict a number. Okay, the output of regression will always be a number. This is a basic difference in between classification and regression. Now let us understand the KNN algorithm. So what exactly is KNN algorithm? So here firstly we decide the value of k. Let us take an example and understand how KNN algorithm works. So let us take an example. Let us say that this red represents class A or the data points in class A and blue represents data points in class B. Now the first step is to find out the value of k. So let us say k is equal to 3. So mostly we consider the value of k like we mostly consider it to be odd number. Why? Because for classification we perform voting and for that reason the value of k should be, we prefer it to be odd, but you can consider any value of k. It can be any number. Now the basic concept of KNN is a new data point will belong or it will behave like its neighbors or the closest neighbors. Like them, new data point will behave. This is basic working or basic principle on which KNN algorithm works. So now I decide what is the value of k. Now what I will do is I will find out, let us say this is a new data point. This one is a new data point. Now I need to predict that to which data point will the new, to which class will the new data point belong to. So now I know the value of k. Now I will find out the distance in between the new data point and all other data points. So I will find out this distance in between all the points and the new data point. So it can be anything. So it may be like the distance in between this and this is 1, this is 2, it can be 3. So there may be multiple distances. Then I will sort these distances. So it will be something like 1, 2, 2, it can be 3 or n. So I will sort these distances and I will only consider top 3 distances because the value of k is 3. So that means I will select only this three smallest distances. Now the distance in between this and new point is 1, and this belongs to class B. Now this belongs to class A. So basically I will write that down. So now let us say this belongs to class A. Then again this belongs to class A. Now I will perform voting. Two of them belongs to class A and just one belongs to class B. That means my new data point will belong to class A. This is how KNN algorithm works. It is a very simple algorithm that pick a value of k. The value of k can be anything, but we consider or we prefer the odd values of k. Then find out the distance in between the new data point and all other data points. Then sort these distances and only pick k smallest values. And then find out the distance. Like after finding out the distance, find out to which, after sorting, pick only the values or pick only the value of k, or like in this case it was 3, so we only pick top 3 or top 3 smallest values or distances, and then find out to which category or which class this belongs to, and then we say that the new data point we perform voting. For classification and for regression we perform averaging, and then we come up with the result that to which class the new data point will belong to. This is the working of KNN algorithm. This is very important that for classification we perform voting and for regression we perform averaging. This is a very important concept. Then as I said, we find out the distance in between the new data point and the and all other data points. There are different ways in which we can find out the distance, like we have Euclidean distance, Manhattan distance, Hamming distance. So there are different types in which we can find out this distance, but we mostly prefer Euclidean distance, or we can also say that Euclidean distance gives us the best results, so we mostly prefer Euclidean distance. But we can use Hamming distance, Manhattan distance, but mostly we prefer Euclidean distance. Then the very important thing, assumptions. What are assumptions? So basically assumptions are the conditions that we consider before applying a algorithm. So like basic conditions that our data should follow, that like if I am planning to use KNN algorithm, there is some criteria, there are some of the assumptions that the data should always satisfy, then and then only I should use this. So every algorithm has its own assumptions, has its own basic conditions. That conditions need to be satisfied before picking up an algorithm and training our model using that algorithm. Like KNN has its own own assumptions, naive Bayes has its own assumptions. Every algorithm has its own assumptions. So just remember what are assumptions. Assumptions are the basic conditions that before applying we should always consider those conditions. Before applying KNN algorithm, these three conditions need to be satisfied, or our data should satisfy these conditions. These are the assumptions. So what are the assumptions? Similar data points. So it says that similar data points lies close to each other. If I will be around data points which are similar to me, then very important thing here, that is all the feature they contribute equally unless they are scaled. So what exactly is scaling? Let us consider an example again. Let us say I have data of two different students, student A and student B. I have two students. One student, let us say it has age of 20 years. Student A is 20-year-old and student B is 22-year-old. Now the salary, or let us say salary of first student is 20,000. Okay, my handwriting is not too good. But yes, and the other is 90,000. So this student is earning 90,000 and this student is only earning 20,000. So when, let us say, I am performing KNN algorithm. So in KNN algorithm, what will I do? I will plot this point and I will try to find out which one is close or which one is far away, right? So what will happen here is this, the salary feature, it has more number of values, like high values, not more number of, my bad. It has very high values. So there is a chance, or mostly the thing that will happen is this feature will dominate more. So salary, this is salary, this is salary, and this is age. So all the features, all the features, they should contribute equally while we are making decision. But in this cases where the values of one feature are very high and the values of other feature is quite small or comparatively low, in those cases the features that are having more number of or high dimensional values, they will dominate the decision, and we don't want this. So basically we perform normalization, we normalize these features. So what we will do is we will divide this by 100. So age we will be dividing by 100 and salary we will divide by, let us say, 10,000 or something. So what will happen, I will get new values in form of 0.5, 0.2, 0.02 or something. So all these features, they will be scaled down to a new range, and both of them will belong to a same scale or same range, both of them will belong to, and this is my aim. So I mostly perform normalization before KNN algorithm because it gets affected by all these values very easily. So this is basically, so the assumption of KNN algorithm is all the features, they contribute equally. Then, very important, the local patterns. Okay, the local patterns in between the classes are more important than the global patterns or overall pattern of that data set or the entire. So we prefer the local patterns or only for that specific class. These are three assumptions of KNN algorithm that we should satisfy or we should consider before applying KNN algorithm. Then the advantages of KNN algorithm. So the advantages of KNN algorithm is that it is a very simple algorithm, so it is very easy to implement as well. So there is no as such training phase required. The model, it memorizes the entire data set because we consider all the data points for coming up with a decision. So it need to memorize everything. So it is quite lazy learner. We don't spend extra time in training phase. Then if we have a data set that has multi-class or multiple classes are present in that data set, we can still use KNN algorithm. And as I said, as I mentioned earlier as well, the most important thing about KNN algorithm is we can perform regression as well as classification using KNN algorithm. So the disadvantages are, when so it memorizes entire data set because we need each and every point to predict. For that reason we need to store the entire data set. That makes, high memory uses. It uses a lot of memory. Then when we have irrelevant features, it don't understand which feature is relevant or which feature is not relevant. So if there are outliers in the data, the decision gets affected because of it. Then when there is imbalance in data, it don't understand anything. It just have one principle, that pick a value of k, find the distance, sort the distance, pick k nearest, and then predict to which class it will belong to. This is basically the disadvantage, that it don't understand anything else. There may be misleading data sets, or there can be like imbalance in the data set, and the prediction or the result will easily get affected by that. Then the applications are in recommendation systems. So it find out, like what are the similar users. Like even I like watching some songs or watching type of videos, or I'm continuously watching the same content again and again. So there are multiple users who are doing this. So in recommendation systems, we prefer KNN algorithm. Then we have different patients having same symptoms, so we group them together. So in medical diagnosis also we can use this. In image recognition as well we can use KNN algorithm. So these are applications of KNN algorithm. In this way we have completed our first algorithm, that is KNN algorithm, which is a very simple algorithm. And in upcoming videos we will be considering other concepts of ML. Also we will be discussing other algorithms as well. That's all for this video. Thank you.